Viscoelastic, or OVD, is sparingly applied to the injector loading bay to lubricate and facilitate the injection process. The injector nozzle is also filled with a viscoelastic. Now we see the lens being lifted from the blister pack by a pair of non-serrated forceps, such as Kellman-McPherson's. In order to ensure correct orientation in the eye, the lens is centrally positioned within the loading bay in a reverse S configuration. Firstly, the edge of the lens is placed beneath the extended lip of the fixed wing of the loading bay, and the opposite edge of the optic is then positioned, taking care to ensure that the haptics are not trapped within the injector wings. If preferred, this may be facilitated by gently depressing the optic to ensure that no part of the IOL is trapped before finally closing the wings and the lens advanced with a slow, continuous and controlled movement of the plunger into the nozzle ready for implantation. Note how the lens moves easily and progressively without any undue resistance. As the lens slowly emerges from the injector tip, the leading haptic gently unfurls into the eye, followed by the symmetrical unfolding of the optic body and the trailing haptic. Should a direct sulcus implantation not be achieved, the trailing haptic can be easily positioned by means of a suitable second instrument. And here we see the lens finally being positioned in the ciliary sulcus. This is an implantation of the Sulcoflex pseudophakic supplementary toric IOL for the correction of residual corneal astigmatism. Note that the pen marks on the eye represent the axis of highest corneal power. The IOL axis of lowest power is indicated by two diametrically opposed marks on the optic periphery. The IOL axis of lowest power is intraoperatively aligned with the corneal axis of highest power. Note the ease with which the lens is rotated into position.